So Google Colaboratory allows you to write and execute Python in your browser with zero configuration required, free access to GPU, and easy sharing. Whether you are a student or a data scientist or an AI researcher, Colab can make your work easier. So firstly, we are going to import the libraries that are required. Here firstly we import the NumPy. NumPy, it is a Python library used for working with arrays, and pandas SPD. It is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built in Python. TensorFlow, it is the open source AI library which uses data flow graphs to build models. It allows developers to create large scale neural networks with many layers. An NLTK is a natural language toolkit which is used to process the natural language toolkit. It is used for building Python programs that work with the human language data for applying an statistical natural language process. So Cborn, next is the Cborn. It is a data visualization library used on top of Matplotlib and closely integrated with pandas. RE is for the regular expressions. Here we'll be using Keras. So Keras is nothing but it's you can understand as simple words as a framework. Like the Keras functional API provides a more flexible way for defining models. It specifically allows you to define input or output models as well as models that share layers. So as I said, we'll be using bidirectional LSTM. We have sklearn for training the data, getting the accuracy score, as well as the confusion matrix in the end. Firstly, we are going to import the data set, that is emotion final.csv, that we have already imported. And as you can see here, it's been present in this dashboard. So it has all the data which is representing the text. We have identified the text and the corresponding emotions that are present. As you can see, it's printing the first head. It's going to give you the output, the first 5 values. I didn't feel humiliated. The emotion which is printed is sadness, and I can go from feeling so hopeless to so damn. That is also sadness. And I'm grabbing a minute to post. I feel greedy wrong. That's angry. I'm very feeling nostalgic about the fireplace. That's love. I'm feeling grouchy. It is anger. So here we are going to find out the df emotion dot unique. Here we are finding out the unique values that are present. We have the unique values that we have identified is the sadness array, love, surprise, fear, happy. And unique is nothing but it's a keyword used to find unique elements in the array. So whichever the unique words are there is going to print everyone. And df.dropNow is going to remove all missing values in the data. And then we are going to define the vocabulary size. And next is the nltk.download stop words. We are going to download the stop words which are present. So stop words are nothing but, as I said, it doesn't add much meaning to sentence. and then we are going to convert it into one hot representation. So here the one hot representation is going to convert our sentences as vectors with one hot representation and pad them with appropriate length for uniformity in input data. So next we are going to create the model. Here we are going to define the embedding vector features, and we are going to use the softmax. Softmax is a dense layer for classifying the output. It is used to convert a vector into a vector of possibilities. So here we have a lot of possibilities, like we have to detect a particular sentence and its emotion that we are going to predict. So it's going to give you the layer, output shape, and the parameter for all the respective layers that are present in our model. And the total parameters that have been identified is 1,093,126, and trainable parameters are the same, and non-trainable parameters are 0. And we are going to train our model, and we're going to store it in the weight.hf file. And here we have to understand that the epochs that we are going to generate is there will be 10 iteration of epochs. So it will give you the corresponding loss accuracy, value loss, value accuracy. Later we are going to print the model accuracy. We're going to represent them using a graph, and how much is the model accuracy, model loss, and that will be stored in the weight.hf file. So as you can see here, this is the weight.hf file which will be generated after training. Then you are going to print out the accuracy score for y test and y predicted. So you get 0.8583 value. Here it's going to print the classification report, y test, y predict, and there will be 5 iterations. And later you will get the confusion matrix, which will be like this. And after training you can predict the emotion. So here you have to add we're defining a predict emotion function using a string, and that's going to identify what emotion is going to be generated after training the model. So here we have worked out with an example. I'm very happy and joyful today. You can work out this model in other examples too, and you just have to write the same function, predict emotion, and write a particular sentence of your choice. I'm going to give you a sentence example. You have to write the function predict emotion and this string, the sentence that you want to predict the emotion of. So when you run, it'll give you happy.